Hi, my name is Angela Hess, and I'm here at the Ginger Lab at the University of Washington, and I will be synthesizing silver nanoprisms today. Silver nanoprisms are very useful because they have a very specific plasmon resonance, and the plasmon resonance is basically adjusted by the size of the prisms, and it's visible through the color of the colloid. First, I will be synthesizing silver nanospheres, and these will be converted to the larger silver nanoprisms by putting them under an LED of a specific color. And based off of the color of the LED, I can get different colors of the resulting colloid. Silver nanoprisms are actually small silver triangles, approximately 20 to 30 nanometers on the side length. And the fact that they're triangles is actually very special because the tips of the prisms experience a strong field enhancement, and the absorbance spectrum is very sensitive to binding particles or the media of the prisms. We're now setting up to do the first step of silver nanoprism synthesis. So each synthesis, we prepare the stock solutions fresh and put them on ice before using. All of the vials are cleaned with acetone, and the sodium borohydride solution is purged with nitrogen before actually adding the sodium borohydride salt. So we use a 250 milliliter 3-necked round bottom flask and put it in an ice bath with a stir bar. We add 95 milliliters of purified water to the flask. And then we start purging the flask with nitrogen. Now we add 2 milliliters of our silver nitrate stock solution and 1 milliliter of the stock sodium citrate. So after about an hour of purging, we add 1 milliliter of the sodium borohydride to the silver and sodium citrate solution. And the solution should turn a very pale yellow. This is a second setup, and this has only been purged for about half an hour. And as we add the sodium borohydride, the color does not change to a pale yellow. Instead, it changes to a slightly grayish yellow, and the hint of gray indicates that it has not been purged sufficiently, and the rest of the reaction will likely not go as desired. After adding the borohydride, we stop purging the solution. At around 5 minutes, we add 100 microliters of sodium borohydride. We will repeat this step at 7, 9, and 11 minutes. Now we mix together the two stock solutions for BSPP and sodium borohydride. We take 1 milliliter of BSPP and 500 microliters of sodium borohydride and put them together on ice. At 15 minutes, we add 150 microliters of this mix to our solution, and we repeat this step every 30 seconds until all of the mixed solution is gone. So after adding the last of the BSPP and sodium borohydride, we let the solution age for about 15 hours, and we stopper the solution completely. And we wrap it in tin foil so that it will be completely in the dark for its aging. We also replace the ice so that it will be cold for the duration of the aging. 15 hours, the absorbance of the sample should be at about 393 or 394 nanometers, and that will indicate that it's been sufficiently aged. After this, we're going to remove from the foil and the ice bath and adjust the pH. The starting pH will be around 9.5 and the ending pH should be 11.0. We are going to use 0.2 molar sodium hydroxide and add dropwise to elevate the pH to 11.0. After adjusting the pH, we're going to pour the solution into small vials that have been cleaned. And it is important to use a plastic or Teflon cap, because if it's a metal-lined cap, the metal will react with the solution. I don't know if you can see that all right. After the pH conversion, I'll take the seed solution and put it under an LED. I wrap it in tin foil to redirect as much of the light as possible onto the solution, and put directly under the LED, and run the LED at about its maximum current. And cover with a black cloth. The conversion process from silver nanosphere to prism the time will depend on the light that's being used, but for most light wavelengths, it will take approximately 12 to 24 hours. After 24 hours under the LED, the conversion process is complete. The shift in color is extremely obvious, and the absorbance spectrum should also display a decrease in the original silver nanosphere peak and the development of a new peak for the silver prisms. And I can achieve, based on the color of the LED, different colors of prisms.